part 3 of our pure substance, thermodynamics and heat transfer. For our third problem, we have water contained in a rigid vessel of 5 cubic meter and a quality of 0.8, and it also has a pressure of 2 megapascals. If the pressure is reduced to 400 kilopascal by cooling the vessel, we are tasked to find for the final mass of vapor and the mass of the liquid. So, internalizing the problem, there's a water contained in a rigid vessel with a volume of 5 cubic meter. Its quality is 0.8 and its pressure is 2 megapascals. If the pressure is expected to reduce to 400 kilopascal by cooling the vessel, what will happen to the final mass vapor and the mass of the liquid of the water inside that rigid vessel? So let's find out. So before solving, we are now going to list our given. We have a pressure that is 2 megapascals and our second pressure that is 400 kilopascal, the volume 5 cubic meter, and the quality X to be 0.8. So in solution, in solving for the specific volume, since we know that we are tasked to find for the mass of the final mass vapor and the final mass liquid of the water, we must first find and solve for our specific volume, since it is a given for us in order to solve for our mass vapor and the mass liquid. We use this formula, the lowercase letter v is equals to the mass of the saturated vapor, mass of the vapor of the liquid and the vapor. So on our steam table, we are expected to find the VF to be 0.00118 plus our quality that is given 0.8 multiplied with the difference of the saturated water vapor and the saturated liquid. 0.09963 minus the 0.00118. We now have this specific volume of the substance, calculated specific volume to be 0.07994 cubic meter per kilogram. After solving for the specific volume, we now proceed in solving for the quality. Let's plug in the result of our specific volume here in this equation, that is equals to 0.0011 plus the X multiplied to the difference between 0.4625 minus 0.0011. We now have the quality X that is 0.1709. So this formula is finding for the quality X. We're going to still, of course, use for the mass of the vapor and the mass of the liquid here. So it is 0.0011 and 0.4625 for our mass of the vapor. Next, for the total mass of the water, the formula of that would be the reciprocal of, the volume over the specific volume of the water. So the volume here is given, that is 5 cubic meter, and our solved specific volume of the water that is 0.07994. We now have the total mass of the water to be 62.55 kilogram. So after solving all the needed values for us to solve for our mass vapor, can now proceed in solving and finding for the mass vapor of the substance of the water itself. So the mass of the vapor is equals to the quality multiplied to the mass of the water. Plugging in all the given values and the needed values, we now find the mass vapor of the liquid to be 10.69 kilogram. After solving for the mass vapor of the substance, we need now to proceed in solving the mass of the liquid to be the difference of the mass of the water minus the mass of the vapor. So we know that we have a mass that is 62.55 kilogram multiplied to the computed value for our mass vapor a while ago, that is 10.69 kilogram. We now find the mass of our liquid, the mass of the liquid to be 51.86 kilogram. In summary, the water is contained in the rigid vessel that is 5 cubic meter in volume, 0.8 in quality X, and a pressure of 2 megapascals. The final mass vapor of the water is 51.86 kilogram, and the mass of the liquid of the water to be 10.69 kilogram under a pressure if it is reduced to 400 kilopascal originated from a pressure that is 2 megapascals. That is going to be the effect of the water under this kind of pressures. So thank you so much for listening, guys, and that could be all for our pure substance problem. Thank you for listening, and goodbye. See you.